A tsunami, derived from the Japanese word "su" meaning harbor and "nami" meaning wave, is a series of ocean waves with extremely long wavelengths and high energy. These waves are usually triggered by undersea earthquakes, volcanic eruptions, or underwater landslide. Tsunami can travel across entire ocean basins, and when they approach coastlines, they can grow in height and unleash destructive force upon the shore. Earthquakes are the most common cause of tsunamis. These seismic events occur when there is a sudden release of energy within the Earth's crust, leading to the displacement of tectonic plates. When an underwater earthquake displaces the seafloor vertically, it can generate a series of waves that propagate across the ocean. The second cause is volcanic eruption. Particularly those that occur beneath the ocean can displace large volume of water and lead to the formation of tsunamis. These eruptions may result in the collapse of volcanic island or the release of massive amount of volcanic debris into the water. As volcanic materials enter the water, they displace water and create waves. The sudden and forceful entry of these materials into the water column generates waves that can propagate across vast distance. The third cause is landslide. A landslide-induced tsunami occurs when a significant amount of material, such as rock, soil, or debris, rapidly move from a higher elevation into a body of water, triggering a series of waves. This phenomenon is often associated with coastal or underwater landslide that can be triggered by various geological or environmental factors. The process typically begins with the displacement of a large volume of material into the water, creating a disturbance. This sudden entry of material can displace a considerable amount of water, leading to the formation of waves. The wave generated by the landslide can propagate across the water body, potentially developing a tsunami if the conditions are favorable. Understanding the science behind tsunamis involves delving into the physics of waves they generate, encompassing key parameters such as wavelength, amplitude, and speed. Wavelength refers to the distance between two successive crests or throat of a wave. Tsunamis are characterized by long wavelength compared to typical ocean wave. Their wavelength can be extended for hundreds of kilometers, which is why they are often described as long-period wave. This characteristic enables them to travel vast distance across the ocean. The second one is amplitude. Amplitude is the maximum height of a wave from its equilibrium position. While tsunamis have relatively small amplitudes in deep ocean water, they can accumulate energy over their long wavelengths. As the wave approach shallower coastal areas, the energy is compressed, causing the amplitude to increase significantly. This amplification is what leads to the destructive force of tsunamis upon reaching the shore. The third one is speed. In tsunamis, they travel at extremely high speeds in the open ocean due to their long wavelength. The speed carries several hundred kilometers per hour, over 500 miles an hour. This rapid propagation across deep water is a critical factor in the limited time available for warning coastal communities. The 2011 Japan tsunami, on the other hand, was a result of a powerful undersea earthquake that struck off the northeastern coast of Japan on March 11, 2011. The earthquake, with a magnitude of 9.0, triggered a massive tsunami that inundated coastal areas and caused widespread destruction. The most poignant aspect of this event was the subsequent Fukushima Daiichi nuclear disaster, which further compounded the tragedy. The tsunami and its aftermath claimed the lives of over 15,000 people and left hundreds of thousands displaced. Just like an earthquake, the sudden movement of the underground rocks produced energy waves that moved the Earth's surface. These waves are called seismic waves. These waves could travel through and on the surface that caused the shaking and vibrations of the ground. The second one is buoy-based detection. Some tsunami early warning systems use a network of buoys equipped with pressure sensors to detect changes in the ocean's water column height. If an earthquake generates a tsunami, the buoy sensor will detect the corresponding changes in sea level caused by displacement of water. The third one is Deep Ocean Assessment and Reporting of Tsunamis DART system. These buoys are located in the ocean area and they can provide more accurate and timely data about tsunami wave. When a tsunami is detected, the boys relayed this information to the Tsunami Warning Center. Early warning systems play a crucial role in mitigating the impact of natural disaster by providing timely information to populations at risk, especially in reducing loss of life. Perhaps the most critical aspect of early warning system is their ability to save lives. By providing advance notice of impending disasters such as tsunamis, people can evacuate to safer areas, reducing the risk of casualties. Next important is minimizing property damage. Early warning also help in minimizing the damage of infrastructure and property. Evacuations and other preparedness measures can prevent or reduce the impact on buildings, roads, and other critical assets. Tsunamis can cause immediate and severe damage to marine life. The force of the wave can crush coral reef, disrupt underwater habitats, and displace marine organisms. Large debris carried by the wave may physically damage or bury marine ecosystems. Besides, coastal landscapes are particularly vulnerable to tsunamis. The waves can reshape coastlines, eroding beaches, and altering the topography. This formation can lead to the loss of critical habitats such as mangrove and estuaries, which serve as breeding and nursery ground for numerous marine species. So now, let's discuss the future challenges after tsunami. First, tsunami can be exacerbated by rising sea levels, which are primarily linked to climate change. As global temperature increases, polar ice caps and glacier melts, contributing to a rise in the sea level. Next one will be saltwater intrusion. Higher sea levels can lead to saltwater intrusion into freshwater sources, affecting drinking water supplies and agricultural lands. This intrusion can have cascading effect on ecosystem, agriculture, and human health, requiring innovative solutions for water management. In conclusion, it is imperative to underscore the critical importance of heightened awareness, meticulous preparedness, and robust global cooperation in effectively mitigating the risks associated with tsunamis. Throughout the discourse, we have delved into various key points that collectively contribute to a comprehensive understanding of the measures required to minimize the impact of tsunamis on vulnerable communities. In essence, the battle against tsunami risk is multifaceted, requiring a synergistic combination of awareness, preparedness, and global cooperation. By embracing these principles, we can strive to create a safer and more resilient world where the impact of tsunamis is minimized and communities are better equipped to withstand and recover from this natural disaster.